Alright, hey, how's it going, Algebra 2C people? Today I'm going to start, this video is going to be on section, as it says right here, section 7.3. And I'm going to do 3 small videos just so that you can kind of do it in your own time and in small spurts. But the name of the lesson is called Simplifying and Multiplying and Dividing Rational Expressions. So the first thing to teach you in the group is to teach you what does it mean to simplify the rational expression. Because the multiplying and the dividing will include being able to simplify. So we start here first. I have the 4 examples that I'm going to do in this. I'll call part 1. Part 2 is going to be strictly focusing on the multiply, simplify. And then part 3, which will actually be the shortest part of them all, will be divide, simplify. Because what it comes down to is if you can understand the multiply video, division will not be very much farther, much more difficult to understand. So anyway, none of these are division or multiplication in terms of fractions, multiple fractions. These are all singular fractions, and we're just going to simplify them all the same way. Again, please remember, at any time you can pause a video to write things down, back it up, and re-hear something if you need to. That's kind of the nice part about these videos is you can go at your pace. So, anyway, we've got these 4 examples here across my boards, and all 4 we're going to do the same process. Step 1, if anything in the entire problem factors, we're going to factor it. That means if there's a greatest common factor, take care of it. If it's a binomial difference of squares, subtraction of perfect squares, that was in the previous video if you reviewed that and looked over just factoring techniques. If it's difference of squares, we do that. If it's a trinomial, you'll see trinomials here, trinomial there, a couple trinomials in example 4 over here. You factor them according to the typical trinomial that we have, trinomial process that we've talked about. Like I said, you have a video that you can review if you need some factoring tips. So here we go. Number 1, the numerator right here, this 4x squared plus 12. The only factoring I can do to it right now is greatest common factor. There is a greatest common factor of 4 there. So I'm going to work these down. So I'll pull 4. If I divide the 4 out of these 2, 4 divides in once, so 1x, and 4 divides into 12, 3. And that's all I've got. I've got this x plus 3 binomial left. The only thing I'm on alert for is if that was a difference of squares, subtraction and perfect squares. It's not subtraction, it's addition. That's done. This denominator, this x squared plus 6x plus 9, that's a trinomial. And I try to break it up like so. And this will work fine. If that's x squared, that's x and x. And what comes to mind when I see the number 9, because I think about what multiplies to 9, 3 times 3 comes into effect. Plus 3, plus 3. And you know how I am, even if you were with me only a short time in class, I always kind of check with the distributive property to make sure that this is x squared plus 6x. X times 3 is 3x, 3 times x is 3x, 3x and 3x is 6x, and 3 times 3 is 9. So yeah, that distributes to x squared plus 6x plus 9. Now, here's the trick. You may only reduce things, numerator to denominator, because that's what you're going to do now, reduce, that are separated by multiplication. There's a multiplication right here. I'm going to highlight these in red if you can see that in the video. Like I said, it's easier to look at that on a computer screen or something bigger as opposed to a tiny little phone. And there's understood multiplication here. Meaning, this x plus 3 group can reduce with one of these because they're separated by multiplication. So, for example, this can reduce reduce this. And we'd be left with 4 over x plus 3. And that's as far as you can reduce it. You couldn't even think about now 4 and 3 don't reduce anyway, but that 3 is touching a plus sign. You can't reduce things that are attached to a plus sign. It's got to be surrounded by multiplication to reduce it. That's why this x plus 3 could reduce, because it attached by multiplication. So final answer. Okay, moving on to the next example. Same process. Anything that can factor, I'm factoring it. This numerator is what I would call a typical trinomial. X and x go there for the x squared. Now, negative 12. I have a few options. Things that multiply to negative 12 that come right to my head are negative 4 or some version of negative 4 and 3, or negative 3 and 4, and some version of 6 and 2. I'm going to go with the 6 and 2 route. I'm going to go with negative 6 and positive 2. If I was to distribute this fully out, it would be x squared minus 4x minus 12. That's the pieces. The denominator. No greatest common factors here, people. The denominator is a binomial. That is subtraction, meaning difference. That is a perfect square, x times x. That's a perfect square, 2 times 2. This breaks up into x plus 2, x minus 2. Once again, highlighting where the separating multiplication signs are. There's one here and there. So if any of those groups on either side of those time sign repeats, numerator, denominator, they reduce. And they do. There's an x plus 2 up here. There's an x plus 2 down here. This reduces with that. Leaving me only, see, now I don't need the parentheses anymore because they were only there because of the times. I have x minus 6 over x minus 2. Final answer. Do not, big mistake that students do tend to make right here is they cross out the x's and they're like, hey, x and x reduce. Oh, 6 divided by 2 is 3. Those are directly attached to a subtraction symbol. They have to be attached to multiplication. And I could prove this to you, just for a second here. I mean, I want you to think about it. If you think, oh, hey, the x's cancel. Oh, hey, negative 6 divided by negative 2 is 3. So you think this all reduces to 3. Put any number for x in there that you want. You will not get 3. I take that back. The only number you could put in for x that would show that is 0. If you put 0 in for these two x's, you get 3. Because it'd be 0 minus 6, 0 minus 2, it would be negative 6 divided by negative 2, which would be 3. Pick any other number in the world that you can think of, you don't get 3. And when you say something simplifies to 3, that means any x you put in place here would give you 3 every single time. Put a 1 in there. 1 minus 6 is negative 5. 1 minus 2 is negative 1. Negative 5 divided by negative 1 is 5. You don't get, so again, you cannot reduce. The lesson here is you can't reduce unless it's touching multiplication on each side. Okay. Next example. I chose this one for 2 unique reasons. Number 1, the numerator, x plus 4, doesn't factor at all. No greatest common factor. It's not a difference of perfect squares. I mean, it's a binomial, but it's addition. And so that's that. The numerator stays. X plus 4. You hear that noise in the background? That's my family watching the movie Mulan. So I decided to come down here and teach instead. Okay, next. This is a binomial that is a subtraction, perfect squares. X, 4, 4. So similar to that one over there, though, that one was x plus 2x minus 2. Because that's 16, it'll be x plus 4x minus 4. Now, again, I told you at the beginning of this problem, I chose this example for two unique reasons. The reason one was, hey, the numerator didn't factor. Not everything has to factor. Here's the second unique reason. Now, there is a multiplication right here separating these groups, which means either of these groups can reduce if they're eligible to with something up in the numerator, and they are. X plus 4 and x plus 4. Now, here's my deal. That reduces with that. And that's where a lot of students are like, well, what happened? The numerator's gone. The numerator's not gone. When I say reduce, notice I haven't said the word cancel. That's what kids say. Reduce means it divides to 1. And that's what x plus 4 divided by x plus 4 is. So technically this reduced to 1. So that's the other reason that I did this example, is because if your numerator completely, as you might say, goes away, it didn't go away. It reduced to 1, so it's 1 over whatever's left. In this case, 1 over x minus 4. And there's that. Okay, last example for this little segment. We have this one. We have trinomial and trinomial. We're going to factor whatever we can. Now this time I'll get you set up early. They both actually do factor. The top numerator, that's x and x as normal. -3. The only way to multiply that is some form of a 2 and a 1 with a negative mixed in. A 3 and a 1. So we're going to use -3 and +1. Once again, if you multiply this out just to check your work, you do get x squared minus 2x minus 3. That's what this multiplies to. The denominator, x and x. Usually what comes to mind when I say multiply to 6 is some form of 3 times 2, which is what's going to work here, by the way. Just don't forget that if it doesn't work, 6 times 1 is an option. This one's going to be -3 plus 2. It can't be +3 minus 2, or this middle part won't work out. Check. If you distribute this back together, you will get x squared minus 1x minus 6. The times, I always like to highlight the multiplications because this is new to an Algebra 2 student. Multiplies here, multiplies here. So the x minus 3 groups, they're separated by multiplication, they can reduce. This is out, this is out. These two groups are not repeating, they stay as is. X plus 1 in the numerator over x plus 2 in the denominator. Final answer. Again, please don't make the mistake of crossing those x's out saying the x's reduce. They do not. They're attached to plus signs. Remember what I said, because if you say that the x's reduce, you're saying the answer is just 1 over 2, a half. That means you're saying pick any number in the world, plug it in for x, and it's going to reduce to a half. The only number that works for, again, is 0, because 0 plus 1 would be 1, 0 plus 2 would be 2, it'd be 1 over 2. Pick any other number. Pick x equal to 1. 1 plus 1 is 2, 1 plus 2 is 3. That's 2/3. You can't reduce when it's attached to addition. So that's segment 1, how to just do the factoring and do the reducing when you're allowed to reduce. The next video, which will be called Part 2, so Lesson 7.3, this is Part 1. There'll be a Lesson 7.3 Part 2 and a Part 3. Part 2 will explore what if we're multiplying 2 of these fractions together. How does that work? So that'll be the next thing I talk about in the next segment, but this will get you through some of the problems we'll assign soon. Take care, you guys.